Well, we're introducing parent functions. And we got several parent functions that we'll be considering throughout this course. Constant functions, linear or identity functions, quadratic functions, cubic functions, absolute value functions, square root functions, reciprocal functions, greatest integer functions, many functions. And a lot of what we'll be doing is what we're going to do here in this problem. Let's see what we got here. Describe the following characteristics of the graph of the parent function. F of x equals the absolute value of x. And then describe it in such a way as to the domain, range, intercept, symmetry, continuity, end behavior, and the intervals on which the graph is increasing or decreasing. And then I've got I graphed the function. I'll show it here on the next slide, but there's some things that we could do right now. Now we know that a parent function of an absolute value is going to have a characteristic V shape. It's going to look something like this. And that's how we can recognize from a graph that we're dealing with an absolute value function. And let's go ahead and do a couple of things, and then we'll go on to the graph and finish, or maybe just confirm. So what about our domain? Well, our domain is, we can describe it as x is an element of all real numbers. There's not anything that's restricting the domain of this. Negative values of x, positive values of x on out to infinity and negative infinity. Now the range, a little bit different story. Let's see, we can do this where the range is y such that y is, if you look at it, it's greater than or equal to 0. And y is an element, there's a little symbol for element, of all real numbers. And we can see that we got one intercept, and it's at the origin, so we got one intercept. At 0, 0, both the x and the y intercept. Symmetry. Well, we can see that we are symmetric. We could fold that in half across the y-axis, so we're symmetric. With respect to the y-axis. And let's see, continuity. Let's go over and look at the graph since I about filled up that slide. A graph of our absolute value function. Well, we're continuous. I can graph that function without lifting my pencil. So we're continuous with respect to all values in the domain. Let's see, what else we're supposed to do? End behavior. Increasing, decreasing. Let's do increasing and decreasing. So we can see here that we are decreasing from negative infinity to 0. And then we are increasing from 0 out to infinity. So we're decreasing from negative infinity to 0. And we're increasing from 0 to infinity. And let's see, in behavior, as, let's write it like this. We got a limit as x is approaching negative infinity, f of x, or y, is equal to infinity. It's going to positive infinity out here. And let's see, that's left in behavior. And then right in behavior, let me change that. I should put negative infinity right there. As x is approaching negative infinity, left in the behavior. As x is approaching negative infinity, f of x is equal to infinity. And then on our right in behavior, we have a limit as x is approaching infinity, f of x, well, it's also equal to infinity. So let's see, we did the domain, we did the range, we did the intercept, symmetry, continuity, in behavior, and increasing, decreasing, and Shazam. We've described the characteristics of the absolute value parent function.